In this podcast, we're going to talk about human impact on aquatic ecosystems. People use lakes, rivers, and estuaries for recreational purposes, like fishing, swimming, or canoeing. Impacts made on a body of water in one area can greatly affect the water quality and life in other parts of the river. So what is water quality? Water quality is the combined state of dissolved oxygen, fecal coliform, pH, biochemical oxygen demand, temperature, nutrients including phosphates and nitrates, total solids, and turbidity in a body of water. Scientists use a variety of tests and assessments to monitor water quality. As a member of Envirothon, I had the opportunity to participate in water quality tests in a nearby bayou.
Through brush.
When it comes on, just hit that button for Sand Run.
Okay.
Major one.
Got
You're
it.
going to be in charge of this since you got some boots.
Stabilizing.
Knew it was worth it getting late on the boots.
Yeah, exactly.
Hey, we got numbers.
Watch them change once I... This is saltwater, right?
Yes, sir.
That'd be really cool. That's why I'm
So
making
that one there, that's 0. That's
Are you
the,
in the water?
that's the salinity.
Temperature, salinity, dissolved oxygen, pH.
Ow, my shoulder.
Alright guys.
Just gotta get this one. I'll show it to you. See the different numbers. Temperature, salinity, dissolved oxygen, pH.
Ow.
Right?
Ow.
You guys see all the numbers?
No.
Yeah.
Wiley, it has record.
Can you see the numbers? No.
Temperature, salinity, dissolved oxygen, pH. You're also getting conductivity, which gives you your salinity numbers. So, I don't know if you guys will be able to see this, but when he puts that in the water, you'll see the salinity will jump up. Go ahead, don't put it on the bottom, just hold it in. Yep. A metal piece can be on the bottom, just try and keep it.
10 or 0.28 on salinity.
Okay, so the temperature of the water right here is 10.3 degrees Celsius.
Frosty.
Our salinity is 594. It's called microsiemens per centimeter. That's really low salinity. This is pretty fresh in here. Numbers that I get when I'm out, they're a lot higher than that. So the salinity actually is reading 0.28. So when I'm testing it out in the bay, like for instance North Bay, I'm getting numbers that are maybe 23.4.
So this is definitely not a spawning.
So this is definitely very fresh. At least where he's got the probes, very fresh water.
Okay.
What is pH?
So the pH right here is 8.8, which is a little high.
Yeah.
It's not horrible. It's not like really basic, but it's not the greatest. It's going down, but and then our dissolved oxygen is 2.3, which is also very low. Dissolved oxygen numbers that I typically get are usually between 7 and 8. That's considered, a normal dissolved oxygen level. So try throwing it out a little farther.
Okay.
Give you some. There we go.
Give it a toss.
Oh wait, so hold on to
Like a
this.
lasso.
Yeah, just let it go out a little bit. We'll see if we get some different
Pretend like
numbers.
you're fishing.
There you go.
Reel her in.
Here's a big one.
So he threw it a little deeper
Dissolved
now.
oxygen.
Now we're getting temperatures at about 9.9, 10 degrees C. pH went down to 8.4. You can see just like a little change like that can completely change your numbers.
So do you take it in certain places
So
to be accurate?
now when
Got
I'm
anything?
sampling, I'll take it at the surface of the water, and then I take it at the bottom. And I'll get a top and a bottom profile of your temperature, your dissolved oxygen, your salinity, things like that.
From all over the body of water and just in one place in the
So,
middle?
for instance, on North Bay, you've got there's the eastern and western sections where that bridge in Lynn Haven is. So we've got 22 different sample spots around that North Bay section. Basically, what you're looking for are areas where fresh water's coming in, or high concentrations of houses that are on septic tanks because they'll leach into the water. And we'll also look for, areas where a road might dead end. Any place that you're going to find that a pollution source is going to be entering the water, that's where you want to take a test. And just make sure that there isn't any actual pollution coming into the water that's high enough to cause you to need to shut down the bay, for instance. So you can reel that back in if you want. Thing for the phosphates and the nitrates and nitrites, we'll fill up a bottle of this size. You're on that duty too, sorry sir.
Look good enough to drink.
This is really dirty water.
Probably not good enough to drink. Expert analysis.
That's why we don't do this.
I'll take some iodine tablets first.
I don't think it would not be good if we drank every sample we got. If it's salty, fish probably live here.
Too salty to drink.
Was it a stab or was it too cold?
So let's briefly discuss a few of the most important water quality factors. First off is dissolved oxygen. Low levels of dissolved oxygen lead to a decrease in biodiversity, and aerobic life forms would struggle to survive in an environment lacking oxygen. Humans can impact levels of dissolved oxygen in several ways, by clearing land and through the destruction of riparian areas, or the plant life adjacent to the body of water. Clearing land can send excess organic matter, like leaves and grasses, into the water. Organic matter is decomposed by microorganisms in the streams, which use up oxygen in the process of decomposition. This leads to an abundance of organic waste in the water, which makes the microorganisms use up more oxygen than can be replaced in the stream. The destruction of riparian areas decreases the shade provided by the plants that used to live along the stream. Without shade, water temperature increases. Warmer water holds less dissolved oxygen than colder water, leading to lower DO levels in the body of water. Low levels of dissolved oxygen cause changes in variety of species. Some species, such as the mayfly or the caddisfly, would not survive in waters with low dissolved oxygen levels. Another factor of water quality is pH. pH is the measure of how acidic or basic a liquid is. The best range of pH for aquatic life is between 6.5 and 8.2 on the pH scale. How can humans affect pH levels in aquatic ecosystems? Emissions from cars and coal-fired power plants can contribute to the phenomenon of acid rain. Acid rain is rainfall made sufficiently acidic by atmospheric pollution that causes environmental harm. Water quality factor, which is phosphorus. Phosphorus is needed for life and is often a limiting factor in the growth of plants. There are varieties of phosphorus, but the type that most impacts aquatic ecosystems are called orthophosphates. Orthophosphates are the phosphates primarily found in fertilizers, and the phosphate group that plants most easily use for growth. That affects water quality is nitrogen. Nitrogen is more naturally available than phosphorus, and is also needed by all living things. The main source of nitrates is from sewage discharged into rivers.
So what's the problem with phosphates and nitrates? They help plant growth, so they must be great, right?
Not necessarily. The problem with phosphates and nitrates comes from its attraction to organic matter and soil particles. Available phosphorus is rapidly taken up by algae and other aquatic plants. Because algae requires only small amounts of phosphorus to thrive, it grows quickly, causing algal blooms. This overabundance of phosphates and nitrates is referred to as eutrophication. An example of eutrophication is found in Deer Point Lake. There used to be only small amounts of algae and plant life in the shallower areas of the lake. But over the years, algae and plant life began to build up. The algae grew up the docks, and it made the stairs slippery and dangerous. Seaweed bloomed as well, and would be hazardous for boating and jet skiing in shallower areas because it would get caught in the engines. The eutrophication of the lake led to a dangerous point of overpopulation of algae. Draining bodies of water releases phosphates and nitrates and reduces the filtering effect of soil and vegetation. The county believed that the source of these algal blooms was mild winters, so they drained the lake to the shallowest it had been in years. This was to expose the algae and seaweed to the air and sun in order to kill it. When they returned the water to its proper depth, they found that the algae was undisturbed. They had unwittingly increased the effect of the eutrophication in the lake because they had misdiagnosed the problem. This demonstrates the importance of accurate water quality testing and knowledge. So let's summarize what we learned in this podcast. First off, people impact water quality. Water quality is a combined measurement of important quality indicators. Scientists take tests in different bodies of water to determine water quality. A few major water quality factors include dissolved oxygen, or DO, and we talked about how humans impact DO levels and how that can sometimes decrease biodiversity. For instance, if a caddisfly could not survive in a body of water with low DO levels, an anaerobic organism or a benthic invertebrate with higher tolerance might be able to survive there. We also talked about pH levels, so how acidic or basic the body of water is, and we talked about the range of life, which is 6.5 to 8.2 on the pH scale. We also talked about how humans impact pH levels through industrial pollution or other means of pollution, and how that can lead to acidic rain, and how that damages the environment. Also, phosphates and nitrates. What's the problem with phosphates and nitrates? We talked about eutrophication and algal blooms. Another one that I could think of is red tide, which is a major problem in Florida. It kills the wildlife, and it's just this algal bloom that is enormous. And so things similar to that are the result of eutrophication. We talked about Deer Point Lake, how it's an example of eutrophication and is still recovering from that today. And finally, I want you to leave here today with an importance of an understanding of water quality and how it impacts us and the environment around us. If you're an anxious biology student fretting about the EOC, then I've been a good person, and I've included some review questions for you. So first off, what is water quality? Secondly, what is the range of life on the pH scale? And thirdly, what does an overabundance of phosphates and nitrates lead to? If you don't remember the answers to any of these, I would suggest going back through the video. And if you need help on any other topic in biology, then I would suggest going through our channel at NBH Sci-Fi, producing science for your education. Algae was undisturbed. Dang it. Questions and... What is this? What is that?
Attraction to organic matter and soil particles. Available phosphorus.
When they return the water to its proper depth, I can't hold the freaking camera straight.
Normally I have a cap for these things, but forgot to bring it, sorry. Oh, you're recording me, aren't you?
Yeah.